Welcome to Train Signal. You're watching Optimizing Virtual Machines. So there's several things you need to look at when you are kind of looking at virtual machine performance and tuning it correctly. First is the guest OS type and version. That's fairly obvious. You know, what you might do to optimize one OS, say Windows, it may not be applicable to another, say Linux. So there are kind of recommendations and best practices that vary between the two, or, whatever different variations of OSs you may have. Proper installation of tools. This is something I still see people that deploy guests and VMs and don't always deploy VMware tools. It's very important for some extra functionality, for some drivers, for memory ballooning, things like that. You should always install VMware tools if possible. CPU configuration, we'll talk about this, but the key here is don't over-provision virtual CPUs. It's not like memory, as I often say. If you over-provision memory and the OS doesn't use it, Vsphare can still, commit it to something else. It can do page sharing. It can use the balloon driver to pull back unused memory, things like that. CPUs are a different animal because it causes issues with the CPU scheduler within Vsphare, and it can cause a higher ready time and cause SMP scheduling problems, things like that. Memory settings, reservations, sizing, swap, all those are considerations you need to look at. Storage and network, obviously. A lot of this can be things like device drivers, paravirtual drivers, VNXNet 3 drivers, or it can also be things like jumbo frames and also underlying physical connectivity that we won't hit on in this lesson, but all those things kind of work together. So when deploying a new VM, be sure to select the proper guest OS. It's not just making, a couple of recommendations. It's recommending the correct NIC driver. It's recommending the correct SCSI driver, some minimums for CPU and memory, but those are really important for the I/O controller, so keep that in mind. It can also affect some other things later, especially things like VMware tools, if it's going to present the right one when you do a tool add, stuff like that, so it's well worth doing. Use TimeSync in the guest. So you've got a few options. If for Windows, you can use NTP or VMware Tools. I would suggest one or the other, but not both, obviously, and that's up to you. I mean, really, VMware Tools isn't bad if your vSphere hosts are already using NTP. Most Windows systems are set to TimeSync anyway, so you just may want to tell Tools not to bother. For Linux, it's suggested to use NTP. And again, choose one, but not both. Also suggest use an OS that needs fewer timer interrupts. This isn't as big a deal on newer OSs. It used to be a problem on older OSs, especially some Linux OSs. Mainly, it's using these little interrupt timers. It does like so many interrupts per second, and the hardware interrupts in the background to kind of set time and keep things in sync. The problem is that chews up CPU. So you'd have an idle Linux VM that was actually using a fair bit of CPU while it was really getting no work done. So we would have to adjust some of that. Use the latest hardware version supported. That's always a suggestion. Just keep in mind you can't go back in hardware version. So if you move up to hardware version 8, but then need to move that VM to an older cluster, that's not going to be possible. So always suggest to do it, especially for new features, but keep in mind that you lose some backward compatibility. And I've said this before, install the latest VMware tools. Stay up to date as best as possible. The nice thing about the newest tools, I know the VCAP's on 5.0, but with 5.1, from this point forward, we won't have to do reboots on a VMware Tools update. A lot of people cheered for that when it came out, and I'm one of them because that was the hindrance on keeping people from updating. So now you can do it, you can update, push them out with Update Manager or whatever, and you don't have to reboot the guest. If you upgrade your Linux kernel, VMware Tools may stop running. So you may need to run this command. It's called vmware-config-tools.pl Perl script, and it'll go through and rebuild and reload the modules for you. VMware Tools installs the balloon driver. So this is a big reason to install tools. Again, the balloon driver is that driver. So if vSphere gets to a point that it's starting to run out of memory, it can go and look at the different guests, and it can tell the balloon driver within a guest to say, look, we need pull some more memory back out of your guest OS. And the balloon driver is a driver within that guest OS that will start asking for memory from, say, Windows or Linux. And usually Windows or Linux will say, okay, I've got some memory over here I'm using for file caching, stuff like that. Nothing with actual active data in it. So it'll kind of shrink that down, hand that memory over to the balloon driver, and then the balloon driver turns around and hands that memory to vSphere. And it's a way to pull back memory that the guest OS have asked for but aren't really actively being used. So that gets installed with VMware tools. If you don't have that, memory overcommit can become a real problem because we have no way to ask for memory back. And eventually VMs grow up to their maximum memory assignment and will start to do things like swap. Hit on this earlier too. Do not assign more vCPUs than required. Very common problem because applications, application vendors or application owners will always say, well, this thing really won't, the vendor says it wants 4 CPUs, so we need to give it 4 virtual CPUs. They don't really understand how the scheduling in VMware works. It's very efficient, and often software vendors way overestimate what they need because they figure, well, you're going to go buy a new server from Dell or HP. You can't buy anything less than 4 or 6 cores these days, so that's what we're going to put as a recommendation. Well, that's a little different once we get in the virtual environment. I can go down to 1 and up to 32. So the more you add, it causes issues with scheduling. The vSphere scheduler, the VM kernel scheduler, has to take those virtual CPUs. It really wants to keep them operating and processing threads on the same physical sockets in the machine because those physical CPUs or sockets have local cache, and you want to keep that cache there. If I constantly move a thread around to different sockets, it doesn't have any of the cache that was there, so it's constantly kind of thrashing the cache and performance suffers. Also with newer systems, we have what's called NUMA, N-U-M-A, and it's non-uniform memory access. And what that basically means is that a CPU is directly connected to memory. If you've got a 2-socket, 2-CPU server with 256 gigs of RAM in it, most likely 128 gig is direct connected to one CPU, the other 128 gig is connected to the other. Now a CPU can access all of it, but it accesses the memory that's directly connected much closer than what's connected to the other CPU. It has to go across the bus. So again, if we have to keep moving things around, the memory may not be local. And if it starts having issues scheduling because you've got a bunch of 4 virtual CPU VMs, and the idea is it wants to try to schedule those 4 vCPUs in each VM as close together in time as it can, because you can't have one vCPU that gets scheduled and then there's a big delay between the next one, because the guest OS is going to see that as what we call skew, and it causes problems. So it tries to do them as close as possible, and eventually it's trying to schedule 4 things at once, and if it can't, it's called ready time, and that's when a VM wants to schedule on the CPU, but it can't. The scheduler says, hold up, I don't have room to do you yet because I got these other vCPUs I've got to deal with, and it's going to sit there idle, not getting work done, and that's called ready time. And you may see a system that's 50% CPU or 60% CPU utilization, but your VMs are slow, and you're not getting as much done because the scheduler's having to back and push back on everything. So the end recommendation here is obviously scale those back as much as you can. Run the application, look at it with 1 or 2 vCPUs. If you actually are hitting limits with those, then add. Don't just do it up front. And within the guest, you want to install the appropriate how. That's a hardware abstraction layer within the guest. That's not as big an issue on newer versions of things like Windows and Linux as it used to be, especially now with almost everything being multi-vCPU, multi-core. Usually you just go ahead and install multiprocessor how. But again, not as big a deal as it used to be. So I just hit on NUMA a little bit. Basically, it remembers that direct attached memory. It makes high-speed memory access from a CPU, but you can have to cross a bus to get to other memory on other CPUs. And you have what's called virtual NUMA. And it exposes the underlying NUMA configuration to the guest, and it requires virtual hardware version 8 or higher. And it's enabled by default if there's more than 8 vCPUs, which is fairly rare, but you can enable it manually. And the idea is, if you notice within the new version of VMware, and really within, say, the older versions too, you could do it without exposing the GUI. You could actually go into the VMX files and do this. The new versions, when you assign virtual CPUs, you can actually say X number of sockets and X number of cores per socket exposed to the guest OS. And what you want to do is try to match your underlying configuration. Now, that doesn't mean if you have 2 sockets and 8 cores each, that you set every VM to 2 sockets with 8 cores each. But you do want to kind of match it. So if you want to start doing like 8 vCPUs, then you're probably going to want to do, 2 sockets and 4 cores each for a total of 8, which matches as a divisor of the underlying physical configuration. This way it spreads things evenly, and the guest OS sees that evenly as well. If you just throw it 8 virtual CPUs, he has no concept of cores, where these things live. He just sees that as 8 different CPUs. We're trying to match that to the underlying configuration. He's going to keep things as local as he can to one CPU, local as he can to the other CPU, and get the most benefit out of that direct memory access and the cache. So we already said use a low interrupt guest. High interrupt guest causes CPU use even when idle. Only use CPU affinity if absolutely necessary. And so this will pin a virtual CPU to a physical CPU. There's a few very specific use cases for this, mainly because you want to tie something. You know, if an application is extremely sensitive to being moved around CPUs and possibly losing access to cache that it had, but it causes unbalanced load and scheduler complexity. Very, very few use cases for this these days, so I don't recommend you do that. And high load can cause increased ready time. We talked about that also. Signs of an overloaded host or too many virtual CPUs. So again, it's not always too many CPUs. Sometimes you just have too much stuff going on. Too many VMs on a host, and you're just starting to really run into density issues. But most of the time, 90% of the time when I see high ready time, it's because people have over-allocated virtual CPUs. Memory configuration. Obviously size memory appropriately. Too little causes thrashing and swapping within a guest. So keep an eye on that. There's less issue over provisioning VM memory than there is over provisioning virtual CPUs, because again, we can do things like transparent page sharing, ballooning, compression, but you know, once you hit compression, you're about to start swapping. But we can do things to overcommit, and guests will only use what they really need. Consider putting swap files on local disk or an SSD cache. That way you're not sending that swap data back and forth across the storage fabric, especially if you're on like 1 gig iSCSI or NFS. And now you can do local SSD caching for VM swap, and it's not a big deal. If you vMotion a VM and it has local swap, it will move that swap with it if there is swap, so it's not that big of a problem. By default, modern servers and operating systems use large memory pages. So as memory within servers has grown, we now go to, memory access within the system uses larger pages. It's not like small 4K pages, it's like larger 2 meg pages. The problem is that when vSphere is using these larger pages, it basically goes, look, the odds of me finding 2 large pages that are exactly the same for doing transparent page sharing is extremely low, and I'm going to waste my time. So I'm not going to even I'm not even going to bother. So it kind of cuts down greatly on what you get out of transparent page sharing. But you can do a couple of things. You can manually force small memory pages using an advanced config option, or when vSphere gets to a high level, I think it's like right at 90% memory usage, it will flip to using small pages and then start doing transparent page sharing. There was actually a bug on this in an early version of when this was first supported on the new Intel processors, and it was causing odd memory utilization reports within vCenter and kind of causing people some concern. But most of the time you don't need to manage this. Just understand that you may not get as much memory overcommit or page sharing unless you start hitting points of contention when it needs to flip to small memory pages. So calculating available resources. This is a hit again out of the blueprint, so it's kind of vague, but I want to walk through this. So first of all, there's obvious physical server configuration. That's about the most you can give a VM, right? It's going to be hard to give it a terabyte of RAM if you only have 128 gig of memory in the server. It's not going to want to do that. You also understand deployed and powered on VMs obviously also consume resources. A deployed VM consumes disk space. A powered on VM is going to consume disk space, memory, and CPU. Then you have memory, CPU, reservations, and limits. And these also affect what you can have. So it doesn't matter what you assign a VM if there's other limits on it or other VMs have reservations, so I can't really give you as much as you think that you get. And that becomes an issue, especially when we start talking about things like resource pools. Resource pools can artificially limit resources as well. We don't hit resource pools too much in this course, mainly because it's hit pretty well within the VCP kind of level knowledge. But if you haven't used resource pools in a while, I highly suggest you go back and revisit those. It's very possible you will see them on the exam. Again, anything up to VCAP level is fair game, so keep that in mind. HA reservation policy, so just because you have 5 hosts doesn't mean you have 5 times the resources of a host. If you're pulling back, 20% resources using a percentage reservation, or you're limiting it based on a dedicated failover host or something like that, that will cut down the available resources to the VMs. Storage config, fairly simple. Use the correct virtual SCSI adapter for your OS. If you can, install the paravirtual SCSI adapter. There's some myths about this adapter. There was a problem very early on where it could actually be detrimental to use it, but that's all been fixed. But I still, people say, well, in certain circumstances, low load and all, or high load and all this, it can cause a problem. Those days are gone. So you can now boot off of it. You can now use it. Some OSs you'll have to install a driver for it, so it may or may not be worth it. If you've got a bunch of deployed VMs, I don't think it's worth going back and retrofitting it unless you've got a VM that's just throwing a ton of disk I/O and you want to squeeze a bit more out. But on new VMs, new Windows 2008 and higher VMs, I would go ahead and use it if you can. It does offer some advantages such as lower CPU overhead and latency and high I/O. But high I/O means different things to different people. I talk to customers all the time who think like high I/O is 500 IOPS a second. That's not high I/O. We're talking thousands of IOPS a second. If you're just doing a couple hundred IOPS, it's again, I wouldn't go back and retrofit this. But if it's new VMs, there's not really any harm in doing it. So it's just kind of pros and cons. You got to weigh that out. Size guest queue depth appropriately. That's a bit of a black art, really. But we've talked about queue depth in earlier lessons around array queue depth, HBA queue depths. You also can have a guest queue depth. Most of the time, I'm going to tell you to leave that as default unless something specifically tells you otherwise. I don't think you're going to hit anything of that magnitude on the exam, but just keep in mind that there is a queue depth there, but I wouldn't worry too much about that. Align the guest partitions with your underlying storage. This used to be a bigger deal, again, than it is now. A lot of things in this world are getting easier, and this is one of them. Any modern Windows OS is going to auto-align the partition when you deploy it. So it's not like it used to be where we had to do some manual partitioning before we would install Windows. There's some tools out there. Nick Weaver has a tool. Nick used to be with EMC, or I guess he's still with EMC, but he had a tool out there. You can search for that for partition alignment, his Uber tool, as we call it. If you've got some machines that need to be realigned, but again, if you install a new Windows OS now, just doing a standard install, it'll partition that correctly. And the reason we do that is because we want to make sure that your partition that the guest sees aligns with the underlying disk, so that when we read, a block of data, it's not crossing these boundaries on the disk, so one read turns into a back-end 2 reads, because now we've got, a sector that the guest sees on the disk is actually crossing between 2 sectors on the back-end disk. So if I read 1 sector of information, the disk has to go back and read 2, and it causes extra overhead. It's not like a terrible amount. Some people say, oh, it's like 30% disk performance by aligning partitions. No. Everything I've seen in testing and all that, it's fairly low, under 10%. But, in some cases, 6-7% disk performance can make a big difference. So if they're not aligned, you may want to go align that. Network config, again, it's going to sound like the last one. Use the best virtual adapter for your guest. If at all possible, use VMX-Net 3. If you can't, for some reason, use Enhanced, and finally use Flexible. There are still some other Unix-based OSs out there that will require E1000, the old Intel driver. It's not always the best, but it works. VMX-Net 3 is the best if at all possible, and then you can install the driver. It's going to give you the most functionality, the lowest CPU use, and the best performance. But, we live in a world of reality, so that's not always an option. If jumbo frames are required, they have to be enabled in the guest. So supported by VMX-Net 3 and Enhanced, but then you have to go into your Linux or Windows guest and actually turn them on. So the driver supports them right away. You don't have to do anything to the driver. The only thing you really would have to do is enable them on your virtual switch and, of course, your physical switches. There's nothing you need to tell in the settings of the VM, but you do have to go into the OS, wherever that is in the OS, and I'll show you in the lab where I do it in Windows, and enable that. Requirements for hot add. So these days we can now, with a lot of current, not a lot, but some current OSs, and I'll show you this on Windows 2008 Data Center, you can hot add memory and virtual CPUs to a running guest. So if you hit a point where you're like, ooh, we need more virtual CPUs on the Exchange server, but I don't really want to shut it down right now because we're in the middle of doing something, and add them, what do I do? Well, you can just hot add and they'll appear to the guest. Some requirements though. Has to be a certain supported guest OSs. I suggest you use hardware version 8. I suggest you install VMware tools. They're required on Linux, but optional on Windows, but I always suggest you do it. And VM must be powered off to enable hot add. So what that means is, if you deployed a Windows 2008 R2 Data Center VM running Exchange on it, and you never go into the settings of the VM and say enable hot add, then you're going to get to a point where you want to add some stuff, and you're going to go in there, and it's going to be grayed out. And you're going to be like, what the heck? I thought this was supported. Well, it is supported, but you have to enable the functionality before you boot the VM. So I've seen more than one person get in trouble where they need to add something because the server's really busy, but they didn't enable it ahead of time. So at some point, they got to shut the VM down, enable hot add, and by that point, they're like, well, heck, I'm just going to go ahead and add the memory and vCPUs while I'm here, and bring it up, which is great for next time, but it didn't help them in the time that they really needed it. So if you think that's going to be something you need, make sure you enable it before you boot the VM. You cannot hot remove CPU or memory. That's not available yet. That'll be neat, but right now we can't just rip hardware out of the OSs. We're lucky to be able to add, but maybe one day we'll be able to remove. Common VM problems. Incorrect SCSI controller. This is an issue. So basically, you have to have a driver for the guest OS, or some come with VMware tools. But if you just go into an existing VM and say, I don't really want to use bus logic, I want to use LSI, and you click it and you hit OK, that machine very well may not boot. So keep that in mind. That's a common issue. I think things like this are great exam-type questions because they're sometimes tricky, but they're kind of definite. It's not a kind of a squishy problem, I'll say. It's something that it's fairly easy to test on. VMs don't boot without adequate memory. So I have seen people accidentally configure 8 meg instead of 8 gig, and vSphere or the VI client will go okay, and it'll let you save the config, but that VM does not boot. Also keep in mind memory overhead. So if you try to really tweak this down, you have to be careful there as well for the hypervisor overhead for each guest. But just watch things like too little memory and the wrong disk driver. Those will cause problems on boot. The other things that you might see are things like, missing VMDK files, or somebody edited a VMX file for whatever reason and made it so that it doesn't point to the right place. Stuff like that. Other than that, my thought is if you hit start on a VM and Windows at least starts to boot, you're obviously seeing the VMDKs correctly. You have enough memory for the VM to at least start. That doesn't mean Windows will have enough to boot, but it's worth checking. And depending on how far you get, normally if you have the wrong disk driver for the selected controller, Windows will blue screen fairly early and say, hey, inaccessible boot device or something like that. So you get some clues on what the problem may be. So watch what actually happens. We already talked about this. Too many vCPUs causes higher ready time. A good point that I forgot to mention earlier is it also adds more memory overhead. In your lab one day, you should go to a Windows VM and give it 2 vCPUs and look at the memory overhead amount on the summary, and then bump it to like 6 or 8 and see how much that makes it go up. It's more than you would often suspect. Now multiply that times 100 or 200 VMs and you see that it can have a big impact. VMware tools, I've said this like 8 times, so make sure you install that for ballooning. And make sure any memory reservations can be satisfied. So this kind of goes back to the resource pools warning that I gave you earlier. But make sure that if you set a bunch of memory reservations, that you can actually satisfy them all when you boot the machines up. If you can't, they won't boot. That'll tell you that there's not enough memory to satisfy it, but keep that in mind when you're kind of planning things out. VMware tools for guest ballooning. Make sure memory reservations can be satisfied. Oh, here's another one. Confirm available swap space. So remember, in the guest OS you have swap files like Windows swap file or Linux swap partitions. But at the vSphere level, a VM has a swap file. If vSphere runs out of space, it will start swapping, just kind of doing this brute force swap of the VM's memory to disk. Each VM has a swap file. Well, it usually has a swap file. The swap file size is the assigned memory. So if I give a Windows VM 8 gig, but I give it a 4 gig memory reservation, that's 8 minus 4, so the swap file is 4 gig. If you give it 8 gig and there's no memory reservation like the default, it'll be an 8 gig swap file. The only time you get rid of swap files is if the reservation matches the assigned RAM. So keep that in mind, that you will have swap file, and you got to make sure there's room, or the machine's not going to boot, because then vSphere is going to get to a point where it's out of memory but it can't swap, and it's going to have a real problem. So it won't let you boot the VM. Lab time. So in the lab, we're going to show VM settings, memory settings, network settings, storage settings. You've probably seen these 1,000 times, but I'm going to show them to them anyway because I want to make sure that you're aware of them for the exam. And then I'm going to show you how to use hot add, which is just kind of like a little bit of fun. So with that, let's go ahead and let's jump to the lab. All right, so here we are in the lab. So let's take a look. I've created a Windows 2008 machine here that we'll use for playing around and do hot add. So let me edit the machine settings. So you're probably familiar with these. I mean, memory settings are here, CPU settings are here. This is where we set the number of sockets and the number of cores per socket. So again, you kind of want to match this with the underlying. If you start doing multiple vCPUs, mainly, if it's 2, it doesn't matter. But if it's 8, it matters, and that's why it kind of defaults to systems with more than 8. SCSI controller, so here's where you change that. You can hit change type, and it's going to kind of warn you about a few things. But if you do think there's a problem, this is where you would come in and alter that. Give you a little bit of a hint. If you're unsure what the default is for a certain OS, just go and do a new VM and just take the defaults, and that'll tell you what the default controller is. So if you get in a bind, you're like, oh, I don't remember which one it is, you can do that. But if you get on the exam and you think this is a problem, maybe they threw something at you where a VM was having trouble talking to a VMDK or wouldn't boot. I mean, there's only a few options in here, so it only takes a second to hit that, hit OK, boot. Nope, didn't work. Bus logic, didn't work. So you can go through here and try them if you want to. But just kind of, again, keep that in mind. VMDKs are good. You want to make sure, here's where you set your memory and CPU reservations and your limits. So look at that. It will show you what the available resources are here using the little triangle based on resource pool or the current host, what your available maximums are. Same for memory. Got that there. So if you do start setting or putting these in a resource pool, you will start to see that you can't limit these to the same numbers. It will actually shrink that down based on your resource pool. Oh, I forgot to enable hot add. So to enable hot add, go to options, go to memory and CPU hot plug. It's actually called memory hot add and CPU hot plug, whatever. But just, I don't know, that's just the naming. Most people just call it hot add. So we enable it for memory, and we enable it for CPU, and you hit OK. It'll make the change, and we'll go ahead and we will boot the VM. And I'll bring up the console here. So again, just keep in mind as we boot, memory things such as resource pools will impact the available amount of resources that a VM can get. So those are kind of all that whole chain that you need to be aware of, and well worth tracking, especially on the exam if they throw something odd like that at you. All right, so it'll be fun. Let's see, because of the resolution. So let's take a look here. Let this redraw. All right. Oop. Finally, there we go. Now, close this. All right, close this. And a couple of things. So first, come here. Task Manager. Back and forth, back and forth. Actually, .800 by 600. There we go. Be less jumping around for both of us there. So we have one CPU, and it shows our physical memory. Total physical memory is 2047, so basically 2 gig in a single vCPU. So let me go up here to Edit Settings. I'm now going to make this, 2 vCPUs and memory, 4 gig of memory. So give that a second to process. And now, let's see, restart Task Manager, and you see we now have 2 CPUs or virtual CPUs and 4 gig of memory. So it's just that simple. All it takes is a supported OS. Windows 2008 is a good test. So if you want to do this in your lab to see the 4 steps that I just showed you, but if you want to, you can go to Microsoft's site. There is a 2008 R2 download eval that you can get, and it will let you do that. And you can install it. It runs, I think, 60 days. And just make sure you select the data center version, because that's the license level that supports this. And then you can go do it. And it's not going to let you do hot remove, obviously. So that's not going to take effect until we restart the VM. So just show you that that doesn't work. But that's it. I know it's a simple lab, but it's well worth knowing the steps for a hot add, mainly that the machine has to be powered off, and then you can go ahead and do it. And this is a quick way to make sure that it works. Go in and know where to set all that. I assume if you've ever deployed a VM, you obviously probably know that. But the big thing is disk controller and understanding what the resources are available to a VM. So with that, we're done with the lab. Back to the slides. And we're done with this lesson. So not a complicated lesson, just stuff that you need to keep in mind as you go through the exam. There's a lot of these things in the blueprint that are just kind of either review or keep in mind, but the goal is to be able to zero in on something very quickly so that you make the most use of your time. So that's it for this lesson. I look forward to seeing you on the next one.